so as we start this next section, this section is actually on finding the inverse of a function. So we're going to begin by doing a quick review on what you remember about functions before we get started. All right, so back a couple of chapters ago when we talked about functions, the definition that we gave for a function was that a function is a rule that relates two sets of numbers. And we talked about an example like y is equal to 3x plus 5. So this rule tells you to take your x value, multiply it by 3, and add 5, and that will give you the y value. Another thing that we talked about with functions was how to tell if something was a function or whether it was not a function. And one way that we did that was by using the vertical line test. All right, so I just want to review that with you really quickly. Remember that in your vertical line test, you are looking at drawing a horizontal line through your function, a vertical line through your function, and if that line touches the graph in more than one place, then the graph is not a function. So for example, in our first problem, if I draw a vertical line, notice that it only crosses the graph in one place. If I draw a vertical line here, it only crosses in one place. If I draw a vertical line here, it only crosses in one place. So I would conclude that this is a function. Whereas if I look at this example and draw a vertical line, notice that my line crosses the graph in more than one place. So this would not be a function. On our next example, if we draw a vertical line here, it crosses in more than one place, so not a function. And also on our circle, if we draw the line straight down, it crosses in more than one place, so not a function. So we learned how to do that using that vertical line test to determine if something is a function or not. The other way that we talked about whether something was a function or not was we looked at a set of ordered pairs. And remember that we always looked at the x values, because in order for something to be a function, we need all of our x values to be different. So in our first example, if I look at my x values, I have 1, 2, 3, and 4. Since all of those numbers are different, I would conclude that yes, that is a function. If I look at the x values in my second example, 1, 2, 3, and 6, all different. So again, yes, this is going to be a function. If I look at my x values in the third example, however, notice that we have a -3 and we also have a -3 down here. So that duplication of an x value means that we do not have a function. Okay, so again, that's just a quick review on what we learned about functions. So the first thing in this section that we need to look at is a specific type of function, which is called a one-to-one function. All right, so this is a particular type of function. Now, these one-to-one functions, a lot of the same concepts that we've just reviewed will apply to a one-to-one function. So let's think about our graphs. So on a one-to-one function, we can use what is referred to as the horizontal line test to determine if a particular function is one-to-one. All right, so what that means is that we are going to take an example that is a function. Okay, now it has to be a function first. So as you recall, this first example was the only one of the three that was actually a function. All right, so we already proved by using the vertical line test that this one is a function. And so now the question is it a one-to-one function? All right, so to determine if it's a one-to-one function, I'm going to draw my lines across. And as long as I only cross the graph in one place, it does qualify as a one-to-one function. And I can see that regardless of where I draw that line, I'm only crossing the graph in one place. So this is a one-to-one function. My other three examples would not be one-to-one functions because they're not functions at all. All right, remember that a one-to-one function is a particular type of function. All right, and then we can do a similar idea as well with the set of ordered pairs. So if it's going to be a one-to-one function, we need to make sure that no y value is the same. All right, so if we look back at this problem, remember that we determined that this one was a function because all of the x values were different. And we determined that this one was a function because all of the x values were different. So now let's check on these two examples and see whether it is a one-to-one function. So remember, in order for it to be a one-to-one function, we also have to have all the y values being different. So look at your y values. You have 4, 5, 6, and 7. So that's okay. All of them are different. That's going to make a one-to-one function. All right, let's look at our second example. We have 4, 4, 5, and 10. So this is not a one-to-one function because we have a duplication of these 4s. All right, and again, we don't necessarily need to check the third one because we already know that it's not a function, so therefore it can't be a one-to-one function.